All right, everyone. Welcome. Not welcome back. I guess this is the first video of the day. But we are in week 6. It's day 2, which everyone knows on Tuesday. Noodle Day, right? Nudie Tues. Um, now it's captured forever. Do I need to restart the video? Just we'll we'll do it live. Damn it. And the reason why there wasn't a part 1 video is because we had some questions, we had some merge conflicts, stuff that really lent itself better to whiteboard lecture, and then we did some refreshers, some warm-ups with Clash of Code. What we're going to do for the second half of today is we're going to have like a bit of a tour. And so what that ultimately means for you all is I don't really have a great homework assignment for you all tonight to coincide with a tour. So I might be giving you a assignment that might feel like busy work. I want you all to keep. You need to keep the momentum going, is what I'm saying, for tonight. And it might not build off of what we covered today, and it may just build off of something we covered 2 weeks ago, which is fine. I mean, it's not a bad thing. I just want to make sure that you feel comfortable making APIs, because in 3 weeks, believe it or not, you will have not made a new API possibly. And so I want to make sure that these are something that you're able to start a new project, you're able to do these kinds of things. So definitely take notes, take good time-stamped notes so that you can come back and watch the video as I'm lecturing over this. I'm not going to be whiteboarding too much. Let's go ahead and get Sketch.io open. Just in case I do need to whiteboard, we've got, oh yes, that is what we have to look forward to here. I'm just going to make a new file. Is that in your way, Zach? Sorry. Let's go ahead and create that. Sweet. So we have our Sketchpad in case we need. 2 main things I want to cover this afternoon. And when we're done, we can go get some noodles. That's how you're all like, just hurry up and get through it then, man. Jeez, why are you dragging this out longer than you need to? Because I can. Okay, so no, we're going to talk about 2 things. We're going to talk about, well, ultimately they're the same thing, cloud hosting platforms. In your mock interview, I will ask you the question, what are some examples of cloud hosting platforms? What do they do? And your answer is going to be, crap, we talked about that in week 6. That's going to be ultimately be your answer. A cloud hosting platform is essentially a platform like, you would have Facebook or something like that. It's an application that you could sign in, have some presence in, and that provides you functionality. That functionality is that you are going to upload your application to it, and it will do, hopefully, everything else that's required to run your application on a server somewhere in a data center. I'm going to try not to use the term the cloud too much, because it's essentially the same thing as, like, brought to you by Microsoft kind of thing. It was a marketing term because the common public, they knew what a server was, they knew what a data center was, but that was like where nerds hung out. The cloud, however, is where, that's where planes are. So then planes are cool. So we can sell the cloud. We can't sell data center. So the cloud, that's essentially the same thing. So we have this idea that we can upload to Amazon Web Services or Heroku. There's another called Rackspace. There's Azure. Like, over the course of the last decade, this has become very popular to have this kind of service. And usually what it amounts to, and we even have our own. Well, we don't technically have our own here in the building. Green Cloud hosts. They like take care of the cloud infrastructure on top of, I believe it's Oracle's product. Red Hat has their own called OpenShift, and they're all varying ways of a company commercializing data center resources. So what the hell does that mean? So traditionally, here's a little bit of a history lesson. Traditionally, a data center was a playground for nerds. And there wasn't really, I mean that in an incredibly endearing way, counting myself in with that crowd. What that means is that if you wanted to interact with a data center, you typically had to call your friend or some representative that worked there and say, hey, I need you to provision these amount of servers into the rack, and we're going to pay for them monthly, and we need like a 3-year lease. So what they do is, instead of you buying those servers from Dell or wherever and putting them in the closet in your building, which you have to be worried that there might not be a fire, all of that stuff, or maybe your building undergoes a terrorist attack or something terrible like that. You don't have to worry about that liability. The data center will give you their high-speed internet. It will give you their redundant storage. They have all of these servers laying around. You are going to pay to access them. So you say, I need these servers, and they'll give you IP addresses, they'll give you hard drives and all that stuff, and you have to pay a ton of money per month over the course of your lease. You're just renting them like you would lease a car. At the very end of it, you don't own those servers. Typically, you'll renew your lease if your application's doing well. And even if your application isn't doing well, guess what? You still have to pay for it. That process can take weeks also to get those pieces of data or those resources provisioned. So depending on how busy they are, you might not get a call back from them until next week and say, hey, we got all your servers going. Here's your IP addresses. You can connect to them. This is your staging environment. This is your whatever. They give you all that stuff, and you can be good to go, and you get a bill in the mail. You have to pay it. Otherwise, they shut them off. Well, that was a really limiting factor. It really allowed only the people who had good relationships with data centers to spin up new applications. So in the later parts of the 2000s, around 2008, 2007-ish, Google and Amazon came on the scene. They had all of these resources, these data center resources they were using to run Google and to run Amazon. They said, we've got a lot of unused servers here. What if we leased out the unused space to developers all over the world? So that they don't have to call a data center, they call us, and it's just one of the other products that we sell. So Amazon was getting into the business of not just selling, deep fryers and goggles. Now they're selling data center resources. So you could sign up and say, I want these servers, and you could buy them from Amazon. And they say, cool, we have a huge distribution network all over the world. So if you want a server in Singapore, we'll spin it up for you. You want a server on the East Coast, we'll spin it up for you. And Amazon and Google also said, you know what we need? We need a fast way to do this, a virtual way to do this. So what they've made is this interface that says that I could log into there, and instead of calling somebody up and saying, hey, can you provision me a couple of servers, and I'll pay per month, and then I won't pay for what I don't use, and I'll pay for what I don't use. They made a little web interface that you could fill out a little form, and that server would pop online in a certain amount of time. And that was the base of a cloud computing, or not a computing, a cloud hosting platform, is that you could go into that platform, log in, fill out the form, and get your server. You didn't have to call the person to say, hey, we need a lease for 3 years. And then that form evolved. You could now turn off a server whenever you wanted to through their web interface. And now this is like the old days of cloud computing. Like this is back in 2000 and, like I said, 2008-ish. Now we're here 10 years later. And we've come a long way, a very long way. Now these things are automated. And so you can imagine what happened with software development and startups when anybody can just say, I want a server. Oh, and by the way, I didn't tell you the price point on these. We're talking anywhere between $14 a month to just spin up a server on demand to thousands of dollars a month, depending on your need. Or you could just spin up a bunch of little servers, have a bunch of like little nanobot servers running that all talk to each other, make your own little server cluster like that. You could do really whatever you wanted to. So over the years, this allowed developers like you and me to just fill out this form and say, I have this server now running in Singapore. I can deploy my Django app to it. I can do a git pull to that server, and I can start my app up, and now it's running. Do all the configuration, do all the DNS configuration, and all of it's running. And now my server is running, or now my application is running on this server, and that server, and this server, all around the world. And that allowed me as a developer a lot of power. No longer did I have to wait a week to get those resources to get up in production, because you can't run your web application on your laptop. You can. The idea of running a server out of your bedroom really is not a production model. Like that's unsafe. It exposes your internal network to the outside hackers. You probably don't have enterprise-grade security firewalls blocking people out of your house. So you want someone else to loan you their infrastructure, and you pay for that. So that's why we have Amazon Web Services and Azure and Heroku and Rackspace and Google Cloud, and so many people are getting into the game now. And Amazon Web Services was one of the first out there, and they have continued to grow their business model. So let me go ahead and AWS. Let me show you where we've got, you have to scroll down past all of the other, like, hey, you like AWS? You should click on Microsoft Azure Cloud. And they're all good. I just prefer AWS because it's a very valuable skill set. AWS has grown. I think they grow like 100 new services every year or something like that. Like at first, really what AWS created was like you had just a computer running in a server somewhere. Like you had a server running in a data center somewhere. You had a database, a managed database that you could turn on, and you had block storage. You had DNS configuration. So you had the whole end-to-end where you could like, I want to buy a domain name, point it at that machine, and then they start scaling on top of that. Like, okay, when that machine goes down, I'm going to bring up another one. And they had these things called AMIs where like their images, or I'm going to bring up, when it goes down, I'm going to bring up a carbon copy of it. And you know what? We were featured on the Today Show this morning, so I need to bring up 20 of them for like 5 hours because we know we're going to get hit. We don't want all of the servers to go down. That put all the power into the developer's hands. So let me go ahead and log in. JTaddy plus AWS, nice. I think this is my password. No, this is not. Super secure password. Nope. Is that my secure password? Sweet. All right, I have multi-factor authentication on, which absolutely everybody should. So that means that I have this little app on my phone that gives me a temporary code. Not a text message. It's kind of like the text messages, but it just gives me a 6-digit number, which if anybody's watching this video, that 6-digit number is completely gone now. So even if they did have my password. So this is the AWS dashboard. I use a good handful of them. There's no way that I could use all of these. My God. Like, if you are a company and you're using all of these, I want to know what your company... You're probably Amazon. Because these services all do super niche things over the course of what you're going to need them to do. Now, we're not going to use any of these today. Like I said, we're going to use Heroku today. But I want you all to have some familiarity with the problem that AWS is solving. So most commonly, EC2 is front and center. EC2 stands for Elastic Cloud Compute. So the C2 is like cloud compute, and E stands for elastic. And EC2 is its most bare metal, basic, like that was the core product Amazon launched. And you can turn on a server, and it can run somewhere. So this is their form that you fill out. Now, I'm not going to actually turn one on, but this is the form that you fill out to say what kind of server you want to turn on. You say, what operating system is the server going to be running on? Amazon Linux, Red Hat Enterprise, SUSE, Ubuntu, Windows Server 2016. You have a deep learning AMI, so if you need to spin up a server real quick that does a bunch of deep learning tasks, this is pre-configured for that. You can also have AWS Marketplace. These are really cool. So you want a server, but you also want it pre-installed with software. Okay, well, we've got Barracuda Firewall. We've got SoftNAS. We've got WordPress. We've got Ghostblog. So when your aunt calls you up and says, can you install a WordPress blog for me? You could go to these community AMIs, and you can install the Bitnami WordPress, which costs $0 extra per hour for the software. You still have to pay for the hardware, which is like on the bare minimum is like $14 a month. But you can just select this, and it will give you all of the instructions that you need to configure and get your WordPress application going. So I can select here. I usually select Ubuntu server. I just know it the best. You can select the size of your server. So this is like what resources are available for it. So a T2 Micro has one virtual CPU and 1 gigabyte of memory. We can scroll down and we can see, all right, let's max out. What are we going to pay? Let's see, the storage optimized, that means it has big hard drives. That means that there are 8, is that gigabytes? internal storage. Yeah, it is about 8 2 terabyte SSDs. So that's 16 terabytes of solid state storage. That's pretty crazy. And I love that it's called metal. It's got 72 virtual CPUs and it's 512 gigabytes of RAM. That's going to cost you. It's just so fucking metal. But see, like these are storage optimized. You can have memory optimized. So these memory optimized ones, this is going to give you it's about 4 terabytes of RAM right here. You can do that with that. The bandwidth has 25 gigabit bandwidth. I believe that is bandwidth there. Network performance, yeah. So, Google Fiber is 1 gigabit. Now this is 25 gigabit in and out. GPU, that's typically if you want to mine Bitcoin. So that's going to, it's much more optimum to process in memory or in your GPU than it is to your CPU, right? You've also got compute optimized, and I like the general purpose ones, for example, because I mostly just use general purpose micro. Like most apps that I create run on micro because only 1 or 2 users are going to be using them. So I pick micro because I don't like to live dangerously. Let's configure the instance details. Look at all this stuff you have to fill out. How many instances do I want? 10. I can even create an auto-scaling group, which sees that once the instance CPU starts to peak, meaning that it's doing a lot of work, it creates another one. And when both of them start to peak, then it creates another one. And then when those CPUs start to calm down, it turns them off. So that's an auto-scaling group. So that way, when in the middle of the night, when nobody's using my app because they're all sleeping, the servers go to bed. And when in the morning, when people start to use them, they all start coming online. So really cool stuff that you can configure here. You can even add storage volumes. I can say what type of storage I want to use. The general purpose SSD is fast. The provisioned IOPS SSD is much faster. Costs a lot more though. And magnetic is very slow. So you can say what size hard drive you want. We're limited by the size of our instance, though. You can add any tags for cost centers or anything, and you can also create security groups. This is where you say what ports are open, those kinds of things. So if I hit launch, that would just create me a computer. I already have a computer running right here. Where is it? Right here. Meteor 2018. This is an app that I have running. You could access this by going to meteor.us. That's my app running on Amazon. That's that whole server. I can show you the details, everything about that. That's just running right there. You connect to your servers by using something called SSH. So let's see. Whoops. If you want to connect to your server, now I'm connected to my server on AWS. I have this file right here is essentially my username and password. I downloaded that when I created my server. Said to connect to here, you need to use this. And to connect to it, I already wired up my DNS. So meteor.us allows me to connect to it remotely. I can take a look at all sorts of stuff. I am literally on another server running in Northern Virginia somewhere, connected through my local computer. I can say grep Python. Look, these are all the web server workers that are running, so that when people connect to my application, these handle the requests. Kind of cool stuff. Looks like it's using Celery too. Neat. So that is essentially the actual computer running. Let's go take a look at, and a lot of these things like Lambda, I think was something that Joe was talking about. Lambda's cool. It's not quite there yet, in my opinion. S3 is one of the other ones that you'll very commonly use. And that's essentially a giant hard drive in the sky. That I use it just to store stuff. Wait a second. Hold on a second. All right, everybody close your eyes. I need to delete this. It's 3 gigabytes up there. How do I delete it? No, that's not what I want you to do. There we go. I meant to delete this earlier. I was storing 3 gigabytes worth of a video game up on there. So I have, pictures. I have some Python stuff running. I think I have my resume up here. Oh yeah, I've got another video here, 94 megs. Headshot. Here we go. Joel Teddy resume. So yeah, you can store like basically whatever you want up here. It's like, easy storage. You create a bucket, which is essentially like a folder, and then you can upload files to it. And then there are no storage plans. You pay for what you use. That's the whole thing with Amazon, is that you always are going to pay for what you use. So if I upload a 3 gigabyte file, I pay for the bandwidth to transfer that data over. I pay for the bandwidth to transfer that data out. So like every time, it's like if all you downloaded it, I'd probably pay maybe a quarter to transfer 3 gigabytes out 3 times, about 9 gigabytes. I also pay for the bandwidth, and I pay for the storage space. And I think the storage space is something like a penny a gigabyte. So it's pretty cheap, but it's definitely not like consumer grade. Like you kind of have to be a developer or someone really tech savvy to use this as your as like, an encrypted storage engine where you just have like link people to go download stuff, like upload a file. Like, you have Imager, right? That's a image storage. Well, you could store all your images up here, way more, or like Dropbox, right? You could put all your files into Dropbox. That's consumer grade. This is not as user friendly. But yeah, Amazon S3. I think it stands for Simple Storage something. Not really something. It's Simple Storage, and then there's another S there. I can't remember what it's called. Very cool stuff. So that's where you'd store like static files, your front-end apps, and things like that. Glacier is essentially the same thing. It's just much cheaper, and it takes a long time to thaw it out. They call it thawing it out because it goes to some other storage. So if, like, say you're a company that has medical records, and the IRS requires you to store those medical records in a encrypted environment for 10 years. Well, you don't want to pay the standard storage engine fee, which is, like I said, it's a couple cents per gigabyte. Say you're going to store terabytes upon terabytes of medical records in an encrypted fashion, and say you never access them. You access them when you get audited, and that might be never, but you have to have them around. So you put them in Glacier, which means that when the IRS or whoever the governing body is comes calling, you say, we can get you those records, we just need 24 hours, we can access them, because it takes time for them to be transferred back. But they're like going down into the basement is what they're doing. RDS, so these databases, these are essentially EC2 machines that have a database configured onto it. So we talked about Postgres. Amazon really wants you to use their Aurora database. You can, you don't have to, but sometimes all you want is a Postgres database. So you can launch a database instance, and it's almost the same thing as going through an EC2 form. So that allows you to just, I want a server. It has to have like 8 billion terabytes on it, 5 million cores. It's gonna cost something like $800,000 a day to run. But that's what we need. I want to launch that database instance, and they'll give you that computer that you need. It's crazy. That's going to essentially be most of the things you do. Where's Route 53? Route 53 is where you configure your domains. You can buy a domain name here. So when you want a domain for, your portfolio, you can say like Kevin, or you can say like Life's Kevin Beach, right? .com. Let's see if that's available. It's available. Life's a Kevin Beach. You can buy that, and you can, right here, you configure it. You can buy it. It will go into your Route 53 hosted zone. You can point it at that server, and now and you can run your portfolio there, and you have Life's Kevin Beach running right there. And you just go to that URL, and it will route you to where you need to go. That's why it's called Route 53, is that it's using DNS, and DNS is really confusing sometimes, but it is the configuration, it's the phone book of the internet. So I have joel.io and meteor.us are my 2 domains that I mostly pay to use. And you can see that joel.io, all the configuration here, this goes all sorts of places. It allows me to go to aws.joel.io. So this is really cool. Like, I have my own little personal login endpoint to log into AWS for me. I've got, crap. I've got game.joel.io. You can't really go to any of those. You have to actually list it, like Impact.js, Maestro. It doesn't list them out, but you can go to each individual one. So like video games that I've created are there. Q Chess is there. All Route 53 stuff. Oh crap, that's gonna be bad. I have to re-log in. Okay, I'm not gonna do that. Okay, so that's AWS. Plus, it's probably good because it's 11 o'clock. So 11 o'clock, our AWS tour ends. That is a very tiny fraction of what you can learn or what you can use on AWS. If that kind of stuff interests you, like you want to be the master, you want to go somewhere on your job and you want to be the person who makes sure that the server's running or brings it back up or takes them down, or you want to be the person that people code to say, hey, can you spin us up 3 new servers so that we can test out this new app that we want to run, but only put them on the West Coast? Like, and you know how to do that. Get good at AWS. You know, those kinds of people, like Joe, for example, at the meetup. His title is Site Reliability Engineer. His main job, is that if the site goes down, there are processes in place to bring it back up automatically. Or if there aren't, he's the one who hops on the phone to get it back up. So literally on his title, you can rely on him that the site is there. If that is something that you want to do, you should look more into this phase of the class. AWS, cloud platforms, all really important stuff. I sort of try to take a 50-50. I want to be really knowledgeable of what these cloud distribution platforms do. I want to know a lot of their potential, but I'm not going to dig in deep on any one of them except for like EC2 and the database one. So like I know what it can do, so in case we need to go explore it, but I'm not an expert really on any of those other ones. So what questions do you have about Amazon and cloud and servers and that kind of stuff so far before we move on?
So this isn't exactly relevant, but I saw it up on the list of, I guess, what would you call like the endbar, like .com, .io, those are like routes or?
That's called a top-level domain, a TLD. So a .com, a .biz, .asia, .io, those are all TLDs. And so that means that there's new ones coming out all the time. There's like .party, .win, .xyz. They're all coming out like crazy. The main part of it, like Joel.io, is the domain name. And then game.joel.io is a subdomain. And you can have infinity subdomains if you own a domain. So, well, not infinity, but you can have a lot.
Do those like render differently, or like what's the appeal of having like a .net versus .com?
Perception. So there used to be some stupid perception that I never agreed with, that if you were like a nonprofit, you'd buy a .org. If you were a commercial entity like a com, you bought a .com. For a while, com was like how you represented yourself. I'm a real company. I've got a .com address. Now that's with all of the TLDs sort of flooding the market, it's kind of gone away. For a long time there, .io was the hotness. People got something.io. Heck, Sketchpad runs on sketch.io. Joel.io is my personal site because a long time ago I wanted to get joel.com, didn't exist because somebody else bought it, and .io domains were fairly new. So I was like, I can get joel.io. It's short. It's kind of got the input output, appeal to developers. Feels kind of techy. It stands for Indian Ocean. And there's actually a lot of political issues with their TLD and it not going to the native people of the islands that they represent. When you've got billion-dollar Silicon Valley companies who are like, hey, we're Trapster.io or whatever it's called, some stupid name. And they're making millions. They're valued at millions and millions of dollars, and they're paying $36, and zero of that's even going to the people who are represented by the IO domain. Yeah, there are problems there. Actually, I haven't been following it recently. They may have resolved that, but I'm pretty sure it's colonialism at its best. Anyways, sidebar.
Saw Amazon had .ninja, that kind of.
Yeah. Oh yeah. You could. I mean, that you don't need to just go to Amazon to buy those. You could go to like Namecheap, and if you just search for your domain, it will like so if we look up like hamburger, right? Let's see if we could buy a hamburger party. Hamburger.party. because why not? Namecheap tends to go slow sometimes, though. But I like Namecheap. They have a good solid service. That's who I usually buy through. I buy through Namecheap and then I transfer to Amazon. Oh, this is probably not giving a glowing recommendation for Namecheap here. But I remember there was one time when I wanted to buy a domain and I was intoxicated, and it was like one of those stupid like drunk purchases, and I was able to go end to end through their purchase flow and get everything set up, and I filled out their customer satisfaction survey and was like, I went through your entire user interface, barely able to use my computer, so kudos to you all. All right, looks like they're not open for business right now. Okay, so let's talk about, what more questions? You had a question, right, John?
Yeah, so like for a portfolio or like for a final project,
Yeah.
is that something we would be spinning up a server on AWS for, or is that more like, is there
Well, since AWS requires a credit card, I want to send this to Heroku. And the thing about AWS is like AWS is very valuable, so you should definitely learn it in your career, or as much of it as you can, because you're never going to learn all of it. AWS is awesome, but it still caters to a non-hobbyist. Like they've done a good job of having a free tier. The free tier only lasts 12 months though. And Heroku started out as being the hobbyist's cloud platform, but you can also grow to being, very highly accessible and enterprise grade. But they changed it a little bit so it was a little bit less hobby friendly. And now they made it so, like if we look at Heroku pricing, I'm going to show you where you all fall into. So over here on the far left, free. And free means that you get a server that has about a half a gigabyte of RAM, has one web worker, which is just like one processor. They don't call them processors though. But it falls to sleep after 30 minutes of inactivity. Now the good news is that you don't pay for that inactivity. Actually, you don't pay for anything, and you could spin up a huge number of these. So you could say, I want 10 free application or free servers, free dynos, and it's great for your portfolio and all of your portfolio applications to be hosted through there. Because if the only people who are looking at your portfolio are going to be looking to give you a job, they might click on something and then like nobody's going to look at your portfolio for probably another couple of weeks. So you don't need those to be readily available. You don't want to pay for them all to be available. So really, what that looks like from a user standpoint, user experience, is that it takes about 15 seconds for the first request, and then it's awake for like a half an hour or maybe an hour. And you get something like a bank of 8 hours a day of availability. So if somebody hits your portfolio application and it was sleeping, it'll sit there and spin for about 15 seconds, and then it will give them your portfolio. And then they'll be able to click all around your portfolio and have fun. Like, no problem. It's awake. And they'll be able to click on any of your other projects that you've deployed. And then those will all be asleep. So it'll be 15 seconds, and then they'll spin up, and then they can click around in that application and have fun. And then they go away, and your dynos will spin down again, and you'll still not pay anything. Now, if you want them to always be available, this is something that you could do, is you could have one dyno that you pay for $7 a month, and that's, say, your portfolio. Your portfolio is always on, so that first request always happens instantly. You go to joel.io, that's my Heroku portfolio, boom, it shows up automatically. And all of your projects are all on the free dyno. So that way, like, even if somebody goes to your portfolio, they see all your all your information, your resume, all of that stuff, and they can even see a list of your projects. But if they click on the project to go see it live on the internet, they'll have to wait like 15 minutes, and then they'll be able to click around and have fun. But if they never click on any of those, they just look at the thumbnail that's on your portfolio because you list them out by projects there. They'll never access it and it won't feel slow. So that's something. You can pay $7 a month for that, or you can jump up to the standard tier, $25 to $500 per dyno per month. I don't recommend anybody do that for their portfolio. You're really just burning money when you don't need to. But the user experience is much different on Heroku from a developer's perspective. And what that means is that when you use, I'm sorry, I need to stretch. That caffeinated gum wasn't doing the trick. When you use AWS and EC2, you're basically saying, I have a computer, I have a computer, I have a computer terminal. And it gives you all of those terminals. So you can like log into that terminal like I did by doing that SSH programs. Like I'm literally sitting there remotely. My terminal is that terminal to that server. So I can do it. I can erase everything on that server if I want, and then my app will go down. So it's bad. It's dangerous. And there's really no automatic way for me to take my application and send it up. I have to do that kind of manually. I have to upload it through other processes. Usually what I'll do is I'll just do a git pull from GitHub or GitLab or something, and I will work that way. So instead of uploading it to it, I'll just download it to the server remotely. But that kind of sucks for a new developer because they have to learn a lot about how servers work and all of that. So Heroku came on the scene, and they said, you know what really sucks about maintaining servers as an application developer? Everything. Everything sucks about maintaining servers as an application developer. You guys didn't want to become web developers because you were super excited. Well, maybe you did, but because you were super excited about turning on and off servers and configuring them correctly. What you all wanted to do is you wanted to make applications. So far we've talked about making applications, Django applications. So what Heroku aimed to do, because there is a lot more to putting an app on the internet than just saying like, hey, put it on a server and run it. You have to have a web server config. You have to have DNS configuration. You have to do all of that other stuff that we aren't going to talk about. We're not going to configure Nginx or Apache to run your web server. You cannot run Django or manage PY run server for your app for a production web server because that can only handle one request at a time. Could you imagine using a web application when only one user could use it at a time, essentially? That would suck. Nobody would use that app. So you need a production web server. So Heroku said, you know what? We're going to make a workflow so that we provide all of that configuration and all that web server stuff, and you hand us your application and tell us how to run it, and we'll take care of everything else. And we're like, yeah, let's do that. And so that's where we are now. Let's do that. So we are going to all sign up for Heroku. So I want everybody to go to Heroku.com or signup.heroku.com. Notice I'm not giving you an affiliate link. I'm not trying to make money by doing this. Just go to Heroku.com and click sign up. And I haven't signed up in years, so I don't know if they ask for credit cards. If they do, though, see if there's a way that you can be like, I want to give this to you later. They don't ask for credit. You already signed up, John?
Yeah, I was the list of things to sign up for.
Oh, did I put that in the pre-work? That sounds like something I would do. Woohoo! Man, I'm really proud of like 6 weeks ago, Joel. Wait, no, that would have been longer than that because I put that pre-work together a long time ago.
Yes.
Fill out that password reset form.
Yeah. Let's get the emails where I'm like, we signed up for this. I wonder.
Great. Well, let me sign in or log in. I have the same thing. I don't know if I remember my password. So let's see. Is it this one? So everybody says yes. Oh, wow. Okay. I've got a lot of stuff on there. I even got some team stuff. Yep. I'm a member of a team. So you probably don't see any of this, right? You just see personal, and then you see new. Don't. What you need to worry about, okay, you don't need to worry about anything, actually, because I'm here. I'm here to protect you, right? Father's Day just happened. Your instructor will not hurt you. I'll scare you. A Salesforce product, by the way, brought to you by Salesforce. When you click on new, so yeah, just watch what I'm doing up here. Don't worry about clicking on it yourself because you might click on the button that charges your credit card $1,000. There is one. There's not one. I'm just kidding. There's one button. If you click it, it's like an instant $1,000. It's just like it pops up like a laughing llama. It's like, haha,
Thanks.
yeah. Let me play my show. Stop it. So where you can create a new app here on Heroku. It's sort of like your GitHub repository. Is that in GitHub you're just storing your code, and in Heroku it's going to give you all of the resources necessary to run your code. It's incredible, and it's gotten really good over the years. I can remember when I first started playing with Heroku, when it first came on the scene, I had no idea what I was doing, and I had no idea what I was doing. So it took me 3 tries of actually like sitting down all night trying to get my application running on the web until I actually got it. And that process probably took me about 3 months to muster up the courage to do it. So they've gotten it down to a science now. But it's not obvious how you do this. Like you can say, I want to create a new app. You can provide it a name, which we're not going to go this route, actually. So let me go and stop doing that. The web interface we're not going to do. We need to install the Heroku CLI. Did I have you install the Heroku CLI? Okay. Okay, so we need to install the Heroku CLI, which is just a brew install. So you should be able to brew install Heroku/brew/Heroku. That's the install that you do. I'll leave this up there for you to type. You type that in your terminal in any directory because it installs to the system.
Okay, it doesn't matter where we are.
Right. When you do a brew install, it doesn't matter what directory you're in. When you do a pip install, that matters what directory you're in. Give you all a second to download and install that. Is it done? Oh, sorry.
How did you
Actually,
get there?
You might have had us do that once at the beginning, but
I Googled install Heroku CLI. But really, this is the command you need to type. Don't put the $sign in it, by the way. When you see a $sign like this, that means that this is like your terminal. So it says, type this into your terminal, but don't type the $sign. Done? Cool, let's wait for Kevin here. We're going to try to get an app deployed in record time. But we're not going to do it the right way. This is going to be like a test. I think tomorrow morning we can show what we did wrong. How about that? Is that installing, Kevin?
Yeah, it's updated.
Cool. Maybe I could run it too. Brew, install, Heroku, brew, Heroku. Because it's deploying or having your app run in a production environment like this, the application itself is not difficult. Typically, you just pass it some configuration. You say Heroku run or git push Heroku master, or whatever, and it's good. The hard part is why did I do that? Don't install Heroku PKG. The hard part is your database and your static files. And that's where I was saying we'll probably have to do it tomorrow the right way, where we configure a database to use Postgres, not SQLite, which is what we have been doing. And that is because Heroku instances the hard drive is not persistent. So imagine a world where every time you turned your computer on, the hard drive was like the exact same as its first time it was booted up. So nothing was ever saved between boots. That's what your Heroku instances, oh crap, brew upgrade Heroku. There we go. Node 10. Wow. Okay. That's modern. Sorry, I should have done this earlier.
So is Brew the application that's like pulling everything to download it?
Yep, Brew is our package manager. So instead of right-clicking and save as and then double-clicking the installer, Brew does all of that for us. All right, so now that we've got Heroku, we need to do a Heroku login. So everybody type in Heroku login. So it wants you to type your login credentials. Those are the exact same as you typed in to log into your account. Okay, the password it stars it, so I just typed that in randomly. Oops. And it should say logged in. You got that all good? All right, so if it says logged in, we're good to go. Let's see, do we want to do this? No, we don't want to do that. We don't want to do any of that. We don't want to do that. We don't want to do that. What we want to do is we want to upload an existing application to Heroku. So let's go pick an existing application and upload it to Heroku. So let's go to our Carolina Code School notes. What was a good one? What's one we worked on like in week 5? Twitter clone. Was that a good one? Front end fun. No, we want API endpoints is what we want. We want the API. All right, I'm going to open up my notes folder, and we're going to see which one of these we want to upload. If anybody has any suggestions, you can't say portfolio. Settings, app. What did this app do? The category. Oh, yes, this is a good one. Week 4, day 2. You remember that one that we had like the contact lists? We had full CRUD for contacts and categories. And we even had a route that said hello world when we went to the / route. I like that one. Okay. So everybody go in your notes directory to week 4, and then the project, I called it day 2. Did you all call it the same thing? Okay, so navigate your terminal directory to go there. So that's our existing project. We're gonna now go doc to documentation. We're gonna say Django Heroku is gonna be what we search for. And May 7th, 2018, that's really modern. We're going to say deploying Python and Django apps on Heroku. Click that. I'm guessing that the instructions have changed. Well, crud. Well, yes, they did update it to use pip file and requirements. Requirements was fine, but now we have to configure a pip file. We didn't do a requirements. Well, that one's not too bad. So let's do exactly what it wants. So we're probably gonna have to go and retrofit some projects to do a pip file and requirements, but that's okay. So where it says day 2, like not the day 2 project folder where it has the settings, but the actual parent right here for day 2. Let's control click and make a requirements file, requirements.txt. And in the same way, let's create a pip file with a capital P for the first P. It's just pip file, not pip file.txt. I actually have never used pip files. That's not my workflow. We use Durenv. So we'll see what it needs to be happy. So we're going to make a new file. So we've got 2 new files. Don't save. Let's save. I'm closing out of some files here that we don't need. Requirements is easy because we could just say we have Django and Django REST framework. Make sure you spell them correctly and we're done. And it looks like this documentation isn't going to be good. It says the conclusive step-by-step guide is here. But I want to point some things out. Know how I said like every time your computer boots, it's like the first time it ever booted. This is where it makes note of that. Your application will not have access to persistent disk storage. Means that persistent means that it sticks around between boots. Looks like it says at least every 24 hours it's going to be deleted. So when your database runs on the same instance of your web server, that's not good because it means your entire database is going to be wiped clean. So you don't want to do that. How to configure, we don't need to worry about that. We will eventually for our database. And this says how we're eventually going to do it the right way. We're going to make a Postgres database with Heroku, and we're going to connect to it. Okay, so this wants a pip file. Boom, boom, boom. We need to go learn a little. I'm going to go learn a little bit more about pip file. I think it's the same thing. Where's my pip file? Oh, so newly created Python applications default to 364. It looks like in your pip file, it's like sort of the envrc. So let's go to our pip file, and let's specify the requires tag, square bracket requires. We're going to say Python version is equal to 3.6.4. So that's the contents of your pip file. If that's really all we needed to do, then that wasn't too bad. Give me one more sec here. Pip file, nothing there. Okay, so I think that we're good then. So I'm going to now link the step-by-step guide in Slack. So this is the step-by-step Heroku Chat Ops. Would you like to install this? No. This is usually what I refer to when we say we want to do something with Python and Django in Heroku. All right, it says we need pipenv installed locally and Postgres installed locally. We're going to try to skip past that. We're going to skip those parts of the documentation because why not, right? Let's click I'm ready to start. We've already done the Heroku CLI. We've already done the Heroku login. I have not cloned the app source code. There we go. There we go. So are you all to the deploy the app step? What we're going to do now is we're going to go to our terminal and we're going to say, where it is in day 2, we're going to say Heroku create using the CLI. Okay, it created the app. Mine made Salty Reef. What is yours called? Enigmatic Coast. What is yours, Zach?
Nameless Hamlet.
Nameless Hamlet?
It's hard to say.
That's a good band name. I call it Nameless Hamlet.
It's mine. It's right here.
All right, I guess I got Salty Reef.
Yeah.
Salty Reef is Nameless Hamlet's first release. What is yours, Kevin?
Mine is Radiant Springs.
Oh, that's a good one. That's a very typical one. All right, so if you paste that link into your browser, look, you have an app running in the cloud already. That's not a Django app, but it's an app nonetheless. You don't copy the HTTPS GET one. Copy this one on the left here. Ah, there we go. Okay, next step. We need to get our code onto that server. Okay, let's see. Let's scroll down a little bit. Oh, it says now deploy your code. So we deploy it using Git. Now you're going to love this. Well, first off, we need to make sure, okay, well, this is not a Git repository. So we need to do a git init. We should be good here. Let's go ahead and add everything. Git add dot, git commit, and we can say initial. Oh, you know what? I think we did a bad thing. But we can fix this. Everybody type git remote -v. Everything is fixable, right? Do you see anything when you type git remote -v? Okay, let's fix it. So scroll up a little bit. John, you remember how I was saying don't click on this Git Heroku link?
Right.
Copy that link onto your clipboard. Okay, everybody got that on their clipboard? Now scroll down. We're going to type git remote. Type it the exact same way that I do. Git remote add Heroku, and then paste that link there. So that's what your command should look like. Git remote add Heroku, and then paste that link there.
So basically, we've created the Git repository. Now we're pointing it to that link and saying push it.
Yes, sir. And typically, if this was already a Git repository, like if our local computer was a Git repository, like we were storing this like you would have anyway, but since it was in Notes, it wasn't. It would have automatically added itself. It would have done this step. But go ahead and do that. Run that.
Well, so wait. So if we're doing this in our assignments, we've already created
The Heroku create will do that if it's already a Git repository.
Oh, so we do Heroku create, and it will say. So then, if we do Git push, if we did origin master, it would still go to GitHub. If we do Heroku master, okay.
Correct. So what John was saying is that the reason we call this remote target Heroku is so that we still have origin. So when you say I want to git push origin, that sends all of your code to GitHub, and it just sits there on a hard drive. Now when you say git push Heroku master, that pushes your code to Heroku, and it redeploys your application. So let's try it, see what happens. It might break. I'm going to say it's going to break. Let's say git push origin, no, Heroku master. Old habits die hard. Let's see what happens. I don't think I'm not holding out a lot of hope, but let's see. No pip file.lock found. Okay. No problem. Mainly they just say, we recommend you commit this to your repository. Well, you can recommend all you want. Interesting. It didn't install any dependencies through the pip file.
Mine did. Mine installed pip and pip file.
Okay, so it says our app is deployed. So if we go back to Salty Reef, or yeah, didn't work for me. You got an application error?
Yeah.
Oh, sweet, there it is. Okay, perfect. What happened? I'm guessing it was this pipenv thing. So let's see what we need to do for pipenv. This is something I've kind of avoided showing you all. I didn't really actually realize that Heroku made it a strong requirement. Let me just see here. It's not to be to boo. Pipenv. Okay. This is probably not going to play well with Durenv. But let's go ahead and pip install pip env. This is going to be so wacky if this works. All right, everybody got that installed? Now we're going to pipenv install Django. And yeah, let's just do pipenv install Django. Sweet. Okay. Did that change anything in our pip file? Yes, it did. Okay, so it updated our pip file. This is good. We're going to also do a pipenv install Django REST framework. And I'm going to fix this, by the way. We're going to make it, I think maybe we can, no, you know what? No. We're not going to go back with durenv. I like how pipenv is working with durenv here. Okay, everybody got all that good? So if let's see, let's look at our pip file. All right, it's got Django and Django REST framework. So let's go ahead and
Mine got a weird error when I was downloading Django framework. It says could not find a version that satisfies the requirement.
is it Django framework or Django REST framework that you typed in? So go ahead and do that. No, and when you do a git status, you'll notice that our pip file is the only one that's modified. So we want to add that and make a commit with it. So we're going to say git add, git commit, added pip file. Sweet. All right, everybody got their pip file in there? So now we should try this again. Let's try git push Heroku master. It's installing pip. Let's see if this installs Django and Django REST this time from the pipenv file or the pip file. Installing dependencies from pip file. Oh, sweet. What broke? The collect static. Ah, yes. A necessary evil. Okay, so see how it says we can disable. Did everybody get the same error? See where it says you can disable collect static for this application?
Still got push failed.
Yeah, you got Ponsus failed to push some refs too. And then
Did you do git push origin?
What?
git push Heroku.
I mean, most of mine looks like that, but it doesn't have that.
All right, well, let's see what your error message was then.
Mine says pipfile.log. Is that name?
Yeah, mine says that.
Your pip file is out of date. Can I take your over your computer here?
Absolutely.
Okay. Your pip files. Let's do this. Let's say, like yours created a pip file .lock,
Yeah.
and mine didn't.
So all we're doing.
That's weird. Let's get rid of that. Let's say git. Let's make a commit where it's. No. I don't want to do that. That's, no. Okay. Let's get rid of the pip file lock file. Let's echo file.lock to git more. Let's see if this fixes it. See if it gets you to the point, because I want everybody to have that same error that I did. All right, while that's working, I'm going to come over here to Kevin's. Let's take a look here. Can I switch over?
Yeah, same.
So I'm going to do the same thing with your computer as I did with Zach. Need a little bit bigger of a window here.
Yeah, I got it.
Got it now? Sweet. All right, so I'm going to rm pip file dot lock. I'm going to echo. Hold on, don't do anything. Can you arrow up for me a couple of times? Or let me see here. Okay, good. Echo pip file dot lock. To dot get ignore. Get add commit. Got rid of pip file. Get push master. So this should get you the same error. Sweet. And on yours, John, it's the same thing. I'm just going to do the same thing over and over again. I'm going to echo pitfile.lock to a dot get ignore file. I'm going to rm pitfile.lock. Add pitfile lock. Get the same error, Kevin? Sweet. All right, well then I feel good that John's getting the same error, even though it's not usually the case. John's always got the crazy weird errors. But this is an error. This is a good error because I kind of expected this a little bit. This is not necessarily the solution we're after, but we are going to disable the collect static step because we are not going to be serving up static files with this application. In your full stack application, you 100% will be. So that is an absolute requirement because you're going to be serving up your HTML and not your HTML, but your CSS and your JavaScript. If you don't serve up your static files, you will have no front-end application to run. So with this one locally, though, just so that we can get some traction, I'm going to copy and paste that failure message where it says Heroku config set disable collect static. That's going to disable that step. When you do config set, that configures your server in the cloud. Isn't that crazy? That's why it says setting and restarting. Now we should be able to push Heroku master. So arrow up DC, get push Heroku master. And we'll see what the next error we get is. That's weird. It didn't install Django or Django REST with pip file. Oh, I guess it doesn't say. It tries to run the command anyway, and then since it didn't run that command, we'll see what happened. All right, so let's go to that URL again. Let's refresh it and see what we get. An error. Ah, crap. Well, what in the world is going on now? Everybody getting the same error? All right, let's type Heroku logs. Let's see what's going on. All right, we're getting a 503. Said that the build succeeded. We sent over some requests. Says no web processes running. That's suspect. Okay. So it says on this step-by-step, we actually have to turn on a web process. You didn't have to do that, used to. But let's do that. So the command to do that is to type Heroku. Type this into the command. We're going to type Heroku ps scale web is equal to 1. I don't know. I shouldn't have. I think I might have. Do I have to redeploy that? Couldn't find that process type. The hell? Oh, wait. on the deploy step, it should have said proc file declare types. Ah, yes, I forgot the proc file. This is weird though because it didn't tell us to do a proc file yet. Okay, so we'll get there, folks. We need to create a proc file. Womp womp. It's easy though. One more file to configure. Isn't this funny? I said you don't have to configure web servers, but you have to do all this configuration anyway. Turns out it's a hard problem to solve. Okay, so in the same directory where we have a pip file in our requirements.txt, we're going to make a new file that's called a proc file. I thought that proc file was required, but that weird thing said that you didn't have to do a proc file. And in here, we're going to define how our web server is going to hook into our worker. So we're going to name it web. So this is saying we're going to make a worker called web, and it's going to run gunicorn, which literally is, you cannot make that called anything else. That is the little local web server that it's running. And do you remember, here's a fun one. Do you remember WSGI WSGI? It's coming back to us now. And the next syntax is that you need to provide the project name .WSGI. You say project file, which is, or the project directory, which is day_2.wsgi. That WSGI file is how your application is going to get served up to the internet, believe it or not. And it looks like there's some stuff in here of log file. Okay, don't really know why we're doing that, but let's do -- log -file -. Okay, so everybody's proc file looks like this, right? Okay, we're going to commit this. So do a git status, commit the proc file. And now we're going to do another git push Heroku master. Now this I expect to work. Notice that every time we deploy, it's like installing pip and doing all that stuff. It wants every deploy to be a fresh deploy. There we go. Proc file declares type web. So now it has a way to connect to the web request. Let's go back to our browser and let's refresh the Salty Reef. It's accessing our server now, so it's waking it up. 15 seconds or so. And we get an error.
So wait, after you did that last push, you ran what?
Nothing.
Okay. Start the DSCL web.
Let me run it. Let's see if we need to. Okay. Maybe that was the problem. So let's run that again. Let's see if, nope, still not running. So I'm going to take a look at my Heroku logs and see if we're getting any errors. App crashed. Well, that's interesting. Still getting 503s. So when you get to this situation, you're just like, what the hell? Why is it broken?
Just throw away your computer and start.
I like that solution. It's not a scalable solution. But notice that it said Gunicorn command not found when we scroll up here. You know what we need to do then? We need to pip-env install Gunicorn. I forgot we had to do that too.
Gunicorn kind of sounds like an amazing mythical creature.
It's pretty amazing. It's like a unicorn with a gun instead of a horn. Okay, did everybody got Gunicorn in there? Pip-env install Gunicorn. Your pip file says it's modified, right? Did it add the pip-env or pip file.lock file back to it? Good, good. So do you see this? This is what you see here, right? Okay, let's git add, git commit, added Gunicorn to pip file. Okay, now I'm feeling good about it. git push Heroku master.
I think we needed to do the scale thing.
No, I don't think we need to do that. You don't typically need to do that. I think that's just one of those, like, you got to jiggle the handle, make yourself feel good about it, and go ahead. I don't think we needed it, though, because it should automatically start up one process for you. But we'll see. So now that we have Gunicorn installed, it's running. I'm going to refresh my app and let's see if it works. Give or take 15 seconds. Hey, there it goes.
I got disallowed.
Yeah, I got the same. Yeah, we got the same.
Okay.
Yep.
You get it worked for you?
No, same thing.
Ah, right. I love it. To fix that issue, go into your settings.py file. You see where it says allowed hosts near the top? Add that star to it. Make your allowed hosts look like my allowed hosts. That's essentially saying everybody can connect to your app. Go do a git add, git commit, git push Heroku master. I'm going to test out that our API endpoints work. Let's see, what were they? What are the URLs? /contacts. Okay, so let's say I go to Salty Reef /contacts and just do a git to that. What the? Oh, we pushed up our database, that's why. You don't usually do that, but it pushed up all our local data too. So there we go. When you go to /contacts, do you see the same thing? It probably looks like this. You know why it looks like this? Because we turned off collect static. So this is what Django REST framework looks like to a user with static not there. And we can just say we want API. Oh, that's actually kind of weird. Oh no, JSON. There we go. That's how it's going to look to our program. And so our API is now running in the cloud. The cloud. We did it. We just had to do a couple of things. I'm glad we got it recorded too. But we'll do this again. I want to make sure that maybe tomorrow what we'll do after we do all the VR fun, if I remember to bring in my computer and all that stuff, it's going to be such a chore. After we do all that, maybe what we could do as a group is deploy each one of our portfolios with the static stuff. Like we'll do that as an exercise, not an assignment. Because it means a lot to me personally that all of your portfolios are online. And so here's another cool thing, is that after your app is deployed, you only have to do that deploy step when you add new things now. We don't have to do this whole configuration setup. Now, when we change stuff in our app, we can git push origin master to save our work to GitHub. And when we git push Heroku master, that does a redeploy. So that's when we have new stuff to add to our portfolio. You just do git push Heroku master. There you go. All right, so
we could work on do several commits to GitHub just to save it, but then when we're actually
when you're ready to
not
go,
making changes for now, then do it.
that's typically what people refer to as hey, we're going to deploy this weekend. Or, hey, we need to have a code freeze because we're going to ship some code. You probably heard people talking like that, right? We're going to ship some code. What they mean is they're going to get the gutsiest developer to sit down and type git push Heroku master, and hopefully they're not going to get a bunch of errors like we did. And if they do, they should know how to figure it out. So You're always going to want to, like, because imagine what you would do. Let's say it's Friday at 5 o'clock. Okay, let's zoom forward. Let's say you got a decent job. You're making about $55K a year, good benefits, good career trajectory, and a lot of solid people that you're working with. We're role playing now. It's 5 o'clock on a Friday, and you want to go, like, you got plans for that evening. You are the deploy master now. You're the person who deploys it this week. So you type git push Heroku master, and it goes through and doesn't give you any errors. And you go test that the app is running at www.centercore.com or something, whatever your crazy app name is. And it gives you application errors from Heroku. What do you do? That's a rhetorical question. I don't want anybody to answer it, okay? You shouldn't know what to do. But that's what your career is. That's what you can expect. You can expect that level of panic that I just put onto all of you in like an instant. You can expect that. Because even when you feel like you know what you're doing, like let's say you've been there for years and you do a Heroku deploy and it doesn't work. You could be a famous developer in your community. Heroku deploy. Our deploy didn't work. And maybe you didn't test it out, or maybe the deploy did work, but one endpoint stopped working. What do you do? That's what your job is going to look like. The good news, though, is that it's not all doom and gloom and terrifyingness, is that you will have somebody hopefully working with you on that. You'll have a phone number of somebody, and hopefully it's not me, but you have a phone number of somebody, hey, I did a Heroku deploy, and we're getting a bunch of errors now. And they'll probably be mad and grumpy, and hopefully they'll help you. But notice what we did. What was our process? What did we do? We looked at the logs. And I've seen this error before. Well, maybe I did, maybe I didn't. We've seen this error before. Maybe we did, maybe we didn't. Then the one where it says Gunicorn command not found. Oh, well, we forgot to install Gunicorn with our pip file. So we add that, and then everything started working after that. There's always a way out.
Can you roll back? Okay, so if we have an app working and then we make changes and we push that to Heroku and then it's screwed up, can you roll back?
So what you typically do there is you'll have branches with Git. And so what you'll typically do is you will have like a branch that is your deploy branch. Like that's production. Excuse me. And if you want to roll back, what you'll do typically is like, so say you move, like you have 30 commits that go up to Heroku that Friday. And something broke, and it was a big one, and no one knows how. And so you work all weekend, you can't get the app back up online. Your boss says, come Monday morning, our customers are going to be very upset that they can't access their app, or our app, and we're probably going to lose some business. So your last-ditch effort after working all weekend on it is to roll back to that previous release tag or that previous release branch. Is use Git instead of saying, hey, this is the most recent release. We are going to switch the branch to use the last release, and then we're going to get push origin or Heroku master. So you've essentially rolled back the deploy by going back to an older instance of your code. So that's how you would roll that back.
And it would still have the latest instance saved on Git, so you could still get that back.
You could still get it back. Like you're with branching and advanced Git methodologies, your code's always somewhere. So if you literally type the word git commit and you make a commit with all that stuff, no matter what branch it's on, and you push, it's somewhere. Like every step you take, it'll be watching you. Anybody? Anyways, there's something called the ref log. And the ref log for a small project doesn't really say very much. But if I was to look for it through a big project, for example, wait, what? Well, I guess the ref log got blown away somehow on that project. Let's go to map. This is really weird that the ref log isn't long. It's only 12 lines long. Anyways, everything you do on Git, if we look at the ref log, you'll see it's not just making commits. Like if you pull, that reference is referred to here. So if you want to say, I want to roll back to just before I did the pull, you would do a git checkout to that number right there, and it would roll your Git repository back right there. And if you say, okay, I want to go back, you say, like, I want to git checkout head now, and that will push everything, that will roll everything forward. So with Git, you can do anything. It's just incredibly dangerous and scary to do it. And that's a good place to end it there, I think. We're going to come back to Heroku because I don't expect you to go through Heroku from what we just had there and deploy your portfolio, because we still need to talk about deploying static files or collecting static files, which is a command, but we should be able to handle it tomorrow before lunch. And then tomorrow by lunch, we should all have our portfolio online. Okay? All right, well, I'm going to end the recording there. Oh, no, audio wasn't recording. Just kidding.